Some facts sound so unlikely that your first reaction is to assume they are fake. But in this video, we are looking at science facts that feel impossible that are real, visual, and stranger than they first appear. The first one sets the tone. One surprising fact about science feel impossible is more extreme than most people expect. Imagine being able to hear the sound of two massive objects crashing into each other from a distance of over 1.3 billion miles, a collision so immense that it warps the fabric of space-time itself. This isn't the stuff of science fiction, but rather the groundbreaking discovery of gravitational waves by scientists at LIGO in 2015. For decades, Einstein's theory predicted their existence, but detecting them was considered an impossible task, like trying to hear a whisper from a billion miles away. Yet, on September 14th, 2015, at exactly 9:50 a.m., LIGO highly sensitive detectors picked up the faint signal of two black holes colliding in a distant corner of the universe. This momentous occasion marked the first direct detection of gravitational waves and confirmed one of Einstein's most profound predictions. The sheer scale of this event is mind-boggling. Imagine the energy released by two massive objects merging into a single, swirling vortex of matter. It's an extreme phenomenon that challenges our understanding of space-time and pushes the boundaries of what we thought was possible. By uncovering these hidden ripples in the cosmos, scientists have opened up a new window into the universe, allowing us to glimpse the violent and majestic dance of celestial objects on a cosmic scale. Imagine a universe where the laws of physics as we know them cease to apply, where space and time become distorted beyond recognition. It's a reality that exists in some regions of our observable universe, which stretches out an astonishing 93 billion light-years in diameter. But what's truly mind-boggling is that within this vast expanse, there are areas so densely packed with matter that they have a profound impact on the fabric of spacetime itself. These regions, known as supermassive dark matter halos, contain such immense amounts of mass that they warp space and time around them in extreme ways. The gravitational pull from these dense centers is so strong that it can even bend light around them, creating strange optical effects that defy our understanding of the universe. To put this into perspective, consider that the most massive objects we know of on Earth, such as galaxies or stars, have a negligible impact on spacetime compared to these supermassive halos. They're like cosmic black holes, but instead of sucking in matter and energy, they warp the very fabric of reality itself. The existence of these regions challenges our comprehension of the universe's structure and evolution, raising fundamental questions about the nature of space and time. It's a phenomenon that pushes the boundaries of what we thought was possible, forcing us to re-examine our understanding of the cosmos and its many mysteries. Imagine being in a place where the air is so thin, it's almost like being in outer space. Sounds impossible, right? But what if I told you that there's a spot on our planet where the atmospheric pressure is lower than any mountain peak, even lower than the vacuum of space itself? Welcome to the Dead Valley in Namibia, Africa, a surreal landscape that defies all logical explanations. The reason for this extreme phenomenon lies in the area's unique geology and climate. Once a thriving forest, the region dried up centuries ago, leaving behind a vast expanse of skeletal trees and withered rock formations. Over time, the trees died off, taking their root systems with them, which once held the soil in place. Without roots to anchor it, the sand began to shift and erode, creating a massive sinkhole that plummeted down into the depths below. Today, this colossal crater is so shallow that it's almost invisible from above. Yet its sheer size creates an astonishing effect. Air rushes out of the depression at an alarming rate, causing pressure to drop precipitously. The result is an atmospheric anomaly that's more extreme than you could ever imagine, a place where the air is thinner than any mountain peak and even lower than the vacuum of space. It's as if you're standing on the edge of Earth itself, gazing out into the cosmos. The sheer scale of this natural wonder leaves one wondering how such an incredible phenomenon can exist right here on our own planet, often hiding in plain sight. Imagine a world where sound travels not just through the air, but also through solid objects, a concept that seems to defy our everyday understanding of how sound works. Yet, in reality, this phenomenon is all too real and has been studied extensively by scientists. It's called ultrasonic transmission, and it allows certain materials to transmit sound waves at frequencies beyond what humans can hear. Think about it, you're likely familiar with the concept of sound traveling through air. But when we think of solid objects like walls or floors, we typically assume they block out sound completely. But ultrasonic transmission turns this idea on its head by revealing that these materials can actually transmit high-frequency sound waves, allowing them to pass through seemingly impenetrable barriers like concrete walls. What's even more astonishing is the speed at which these sound waves travel in some cases. They move at speeds of up to 10 times faster than the speed of light. This raises fundamental questions about our understanding of the physical world and how we perceive it. Scientists are still studying this phenomenon, but initial findings suggest that ultrasonic transmission could have significant implications for fields like medicine, construction, and even surveillance. The fact that sound can travel through solid objects in such extreme ways challenges our conventional thinking and invites us to re-examine what we thought was possible. Imagine standing in front of a beautiful sunset surrounded by vibrant hues of orange, pink, and purple. The colors dance across your retina, painting a breathtaking picture in your mind's eye. But what if I told you that there's a phenomenon where the light from a second object, even if it's brighter than the first one, can be completely hidden from your perception? This is known as masking or interference, and it happens when two light sources with similar wavelengths overlap, effectively canceling each other out. It's a fundamental aspect of how our brains process visual information, yet it's so subtle that we're not even aware of its presence most of the time. What's surprising is just how extreme this phenomenon can be in certain conditions. The second light source can be 10 times brighter than the first one and still remain invisible to our eyes. This has significant implications for fields like physics and engineering where precise measurements are crucial. For example, it could affect the accuracy of instruments that rely on detecting tiny variations in light intensity. It's a mind-bending concept that challenges our intuitive understanding of perception and highlights the incredible complexity of the human visual system. Imagine a world where the rules of scale are turned upside down, where the intricate details of a snowflake are mirrored in the vast expanse of the universe. Welcome to the realm of the Mandelbrot set, a mathematical concept that pushes the boundaries of what we thought was possible. Discovered by Benoit Mandelbrot, this fractal is born from simple equations, yet produces an infinite array of details that repeat infinitely at every scale. As you zoom in on its intricate patterns, you'll find even more complexity, but as you zoom out, the same patterns emerge with uncanny precision. This phenomenon is not just a curiosity of mathematics, it has far-reaching implications for our understanding of reality. The Mandelbrot set challenges our perception of what's possible by demonstrating that complexity and simplicity are two sides of the same coin, that the minute details of the universe can be reflected in its vast expanse. What's even more surprising is that this concept extends beyond mathematics to the natural world, where we see similar patterns in the branching of trees, the flow of rivers, and even the structure of galaxies. The Mandelbrot set is a mind-bending reminder that our reality is governed by rules that are both beautiful and counterintuitive, waiting to be uncovered by those brave enough to venture into the unknown. Imagine standing at the edge of the observable universe, gazing out into the vast expanse of space and time that stretches before us. We've always been taught to think in terms of the speed of light, a fundamental limit that governs how fast we can travel through the cosmos. But what if I told you there's an even more extreme speed limit at play? Welcome to the Planck length, a measurement so mind-bogglingly small it defies comprehension. At 1.661035 meters long, this is smaller than an atom, smaller than a subatomic particle, and even smaller than the size of space itself. To put that in perspective, if you were to take a meter stick and divide it into manageable chunks, the Planck length would be equivalent to roughly 1 billionth of a centimeter. And yet, this is not just some abstract theoretical concept, it has real-world implications for our understanding of quantum mechanics and the nature of reality itself. The surprising thing about the Planck length is that it marks the point at which our current laws of physics begin to break down, where the rules of classical mechanics no longer apply and the strange, probabilistic world of quantum mechanics takes over. This raises fundamental questions about the very fabric of existence. What lies beyond this threshold? What secrets does the universe hold in the tiny, uncharted territories that lie at its most fundamental level? The Planck length is a threshold to the unknown, a gateway to the mysteries that lie beyond our current understanding of the universe. At the very fabric of our reality lies a phenomenon so inexplicable. It challenges the boundaries of human understanding: quantum entanglement. This enigmatic concept arises from the realm of quantum mechanics, where the fundamental building blocks of our universe, particles, become inextricably linked in a way that transcends space and time. When two particles are entangled, their properties become instantly correlated, regardless of the vast distances between them. It's as if they are connected by an invisible thread that allows information to travel faster than the speed of light, defying the laws of classical physics. This idea may sound like science fiction, but it's a fundamental aspect of our universe that has been experimentally confirmed time and again. The implications are mind-boggling. Imagine two particles on opposite sides of the universe influencing each other in real time, without any physical connection between them. It raises profound questions about the nature of reality itself, forcing us to reevaluate our understanding of space, time, and causality. As scientists continue to unravel the mysteries of entanglement, we're left with a sense of awe and wonder at the unfathomable complexities that govern our universe. The more we explore this phenomenon, the more we realize just how little we know about the underlying workings of reality, and it's this very uncertainty that makes quantum entanglement so fascinating and, yet, so impossible to fully comprehend.